Okay, did it work? Did it work? I just rebooted. Okay, can you confirm if you... Hello, is it here? Yeah, I'm back here. Okay, I'm back. Okay, so YouTube, I don't know what happened to YouTube now. I guess it starts a new... YouTube starts a new video. YouTube does not recover. So on YouTube, you have to click on it again. I wish YouTube had a better way of recovery from some of this, because it's really hard to recover when this occasionally happens. Because it does, you know, I don't know why it happens. It's like bad internet, and I just get it, and so let me see if you can see it here. Okay, here we go. Okay, so there's only a couple of people on YouTube right now. So we lost everyone else. Okay, so wow, that's so disruptive, you know, with such a good discussion, and then we lost the signal. Very, very distressing. Okay, so anyway, Twistman is back on YouTube. So thank you for coming back. And we lost so many of you here. Lost so many of you. So hopefully just let this build up here, and we'll get everyone back in a second. I don't know what happened. I just looked at it, and it turned red. Like I lost internet. So Nomad is back. That sucks. Yes. Quentin is back. Okay, so what's I talking about? So back to topic here. Back to topic. So when we're talking about radio waves or electromagnetic waves, they're not necessarily radio waves. They're electromagnetic waves. We get all of them, and any amount of waves given in excess is energy. And obviously, you know, if I subject it to any kind of energy that is powered by electricity, this is electric. RF is it's magnetic and electric. So forgetting about the magnetic for a moment, just think about the electric side. Simply getting close to something electric will obviously affect you just from the heat point of view. So electromagnetic means there's an electric component there, and the electric component alone will generate the heat. So if somebody said, well, you know, I don't care what frequency it is, if you you know, if you get it, then you're gonna get some sort of cell damage. You know, that's a bit of a reach, medically speaking, because you know I did study medicine. It's a reach because of the specific effects of what happens with ionizing radiation. So let me just pick a chart here. I'm going to pick a chart because I want to show you what we're talking about here. Because we're talking about something called ionizing radiation. Not all radiation is ionizing. I'm just looking for where that chart is. And actually, I will show you a video. I'll show you a video of the actual radio waves as it exists today. And you can see, you know, here we go. Ionizing radiation. Okay, so there's the different types of ionizing radiation. So the thing is that ionizing radiation has a measured effect, so that when you subject yourself to ionizing radiation, you can actually see the effect of it. Well, one of the effects of ionizing radiation, that's it starts at ultraviolet and above, meaning at the higher range of frequencies above visible light, is that it causes separation of electrons from atoms, and it causes, specifically on DNA, it can cause bonds to break on DNA. So your DNA bonds will break. When the DNA bonds break, then you actually do permanent damage to your DNA, and your body will start to make unknown proteins. It's a measured thing. I mean, we do it all the time in molecular biology. You bombard bacteria with UV light. That's all we use, UV light. And you bombard the bacteria with UV light, and you look at it again, and you will see. Well, it will not recover either. That's not necessarily true, because we're talking about bacteria, or single-celled organisms. You have many, many cells. So you can have some cells that break up and the rest may not be. That's not necessarily true of all of your cells. For example, your hair cells regrow. It may be true of cells that do not regrow. Yes, but all of your body has DNA. So DNA is in every cell. So you may destroy the DNA of some cells. But one of the things that happens when you destroy DNA is it makes unknown proteins, or proteins that you don't expect it to make. It'll start making, because that's what DNA is. It makes proteins. That's what the purpose of DNA is. So if it's like taking unknown drugs. If you take if your proteins if your DNA becomes damaged, it creates disproportionate amounts of what it should normally make, and that may affect you. It's like taking a drug. So in bacteria, we actually fire up. So when in molecular biology, you take the bacteria, and then you blast it with UV light, and then you use it to check for mutations. And there will be mutations that you will not see. The mutations don't exist in the same degree when you do not have UV light. So meaning we don't see any significant amounts of increase in mutations at visible light or anything below UV light. So that's just a fact and reality that's easily measured. Okay? So some of you are saying, well, yeah, but, one of the biggest issues with 5G is that they said, this is the theory actually that they say. So this is the theory that needs to be debunked. They said because 5G uses millimeter waves versus the current 3G uses centimeter waves, so centimeter size waves, and 5G will use millimeter size waves, quite a bit smaller. Hello, Ash. Quite a bit. Hello, open source. So current waves for cell signals are in the centimeter range, and they're going to be in the millimeter range when you get to 5G. So the question that's being said is, since millimeter waves do not have good reach, this is the theory that they have. Millimeter waves don't have good reach, so they're going to bombard us with a lot of power. Meaning, if the power of the cell signal is X, it's going to be 50X or something like that. And therefore, you're going to get an overload of frequency signal, because the assumption is that the only way that 5G can work is by having an increase in power. This is actually quite false. This is actually false. 5G is not actually going to be driven by more power. I'm going to show you a little video here to show you that I was actually scanning, and I'm going to show you what you're looking at. I'm going to actually show you a video right now of the frequencies you're experiencing today. Okay? So let me just make this smaller here. Then I'll explain to you what you're looking at. Then I have to restart the video. Okay, so this one is, let me restart the video. So let me restart it. Hold on. Okay, look at the top there. So this is in the ham band. This is at 446 megahertz. 446 megahertz. This is in the ham band, which is about half the frequency of a cell tower. And I'm showing you the typical signal. Now you can't see this, so I'm gonna just show you that the top band is 0, and I believe that the bottom band is minus 27 or 28 dB. Okay, so I'm keeping it to the same. I'm keeping it to the same range. This one is FM radio. FM radio is quite powerful, actually, if you think about it. This one is air traffic control. This is air traffic control. Okay, that's an air traffic control frequency.
High elevations. Friday night and Saturday.
This one is NOAA, the NOAA weather announcement for weather. So if you want to listen to weather, it's on this channel range, and that's actually pretty strong. It's a very strong signal. Okay, this is what you're looking at here is your cell tower signal. Now look how low it is actually. That's the signal from the cell tower. It's pretty low. It's quite low. Then I'm showing you that a range because they transmit in a range. The other one was probably one carrier, there's another carrier, and these are the actual cell phones in the area. So these are the actual cell phones emitting traffic in the area. This is around 861 megahertz. This is where your normal 3G traffic is. This particular device that I have here doesn't go into LTE, which is at 1.9 G. It doesn't show you that, but it's about the same. I have another device that can show it, and it's about the same. Okay? So this is the traffic. That was the traffic the last showed you was for 3G. 3G. So currently you're experiencing that kind of signal load right now. That's what you're experiencing right now, is that signal load. Now, I'm next to this device. This is my Tor router, VPN router. This has 5 gigahertz. This is 5 gigahertz Wi-Fi. Okay, so this is a 5 gigahertz Wi-Fi router. It's emitting 5 gigahertz for me. And I'm sitting right next to it. You're sitting right next to your if you're near your Wi-Fi router, that's operating at 2.4 gigahertz, which is microwave frequency exactly, and 5 gigahertz, which is this. This is double that. Okay, so most of you are on 5 gigahertz Wi-Fi or on 2.4 gigahertz Wi-Fi. Many of us are on 5 gigahertz Wi-Fi. So you are subjecting yourself to the frequency of this as well. Now, if I showed you in the chart what the actual load is, it will be equally low in the chart. Now, there's a reason for this, because the FCC does measure what we usually use, and the FCC keeps it at a certain level. That's why if you look at all the signals, they tend to be in the same rough level. Okay, and to give you kind of an idea of how this translates to the real world here, so let me just show you an example. That's not the software full moon party. That's hardware. That's you have to have a software-defined radio receiver. In my case, I had a receiver transmitter, which is this. And then use the software to give you the spectrum analysis of the radio waves. So I can scan the radio waves from the bottom end to the high end. I have a machine that can spot all these frequencies all the way to 6 megahertz. Okay, so this device can check all of the RF from the lowest to 6 megahertz. I don't have a device that can go higher than 6 megahertz. So I can't check the projected Wi-Fi, projected 5G use case because that's beyond my device. But we're going to talk about some of the theories that they have about how they're going to use this. Okay, how high? So this one goes to 6 gigahertz. But this is a transceiver. It can also transmit to 6 gigahertz. You can buy a similar one called Hack RF1, similar device that can go from like 70 megahertz, 70 kilohertz to all the way to 6 gigahertz as well. So I can detect 4G. Yes, I do detect 4. Yeah, I can see 4G, but not on the one that I showed you. I was using a different device there. So I detect 4G, and I'm telling you right now, I go to 4G and it's about the same strength. So 4G, 3G, all of that's about the same signal. Just to give you a comparison here, okay? To give you a comparison, your microwave operates at about 1,000 watts or 1,200 watts. Okay, so it's transmitting microwave at between 1,000 to 1,200, between 800 to 1,200 watts, a typical microwave. The small ones at 800 with a tiny space. The big ones at 1,200 watts. 1,200 watts. Okay, I just want you to understand that. Okay, this cell phone transmits at a quarter watt normally. It can actually increase the wattage if it can't find a signal, but in normal operation, this phone is transmitting at a quarter watt. Now, there's that's for cell. There may also be a wattage that concerns Wi-Fi. So between Wi-Fi and cell, it's transmitting two kinds of signals. And this is transmitting at a quarter watt. Okay? This radio, which I can use to communicate with a repeater as far as 50 miles away, can transmit from 1 watt to 8 watts. So this is, and you need a license to go beyond that, okay? To the higher wattage. So I have a license, so I can use this to 8 watts. But if you don't have a license, typically they're not even going to give you a radio that goes beyond 1 watt. So if you're using an unlicensed walkie-talkie radio, it's not going to go beyond 1 watt. Okay? These are important comparisons here. Okay, a Wi-Fi router, the actual physical router itself, these routers. So the routers in your home that does the 5 gigahertz or 2.4 gigahertz, they're topped out at 1 watt. They can't go more than 1 watt. That's a maximum for Wi-Fi in your house. 1 watt. Is anybody still here? Did everyone leave when I got disconnected? I don't know. It's like it became ultra quiet. Okay, 1 watt. How far is the closest cell tower to my house? Well, it depends on, I think for T-Mobile, could be a quarter of a mile, maybe. I'm thinking. That's, I think it's a T-Mobile tower, but I'm not sure. Still here, just listening. Okay, so this one transmits at 1 watt. Now, remember, your Wi-Fi is pretty much next to you. So this one is next to me, and it's transmitting at 1 watt. This phone, if it transmits, will transmit at a quarter watt. No, there's a 1 watt is the max. You can max it out to the FCC limit, which is 1 watt. So you can change country and change it to the highest wattage, but U.S. is already at the highest. Okay, 1,200 router at the same time can toast me. So if you have a router transmitting at 1,200 watts, Zoc, that will toast you. Yes. If you have a router that's, can you imagine putting in your house, 5 gigahertz routers at 1,200 watts, the same power as a microwave? Don't get near that thing, because there will be this electrical energy in there. electrical energy. I mean, forget about the cell damage and all that. It's electricity. So if you even get in contact with an antenna at 1200 watts, you're going to get a burn. It's called an RF burn because there's electricity in it. I don't know if you understand about electricity, but if you put electricity next to metal things, it actually causes inductance. Inductance is the term. So the current transfers. Okay, so anything with that kind of wattage will definitely transfer something called inductance. It'll pass electricity to you. So forget about, all of these other things that you're talking about. Definitely it's damaging because of electricity, which will generate heat. So that has nothing to do with cell damage. You will get cell damage, but in a different kind of way. You get cooked. So that's pretty easily measured. You get the fucking hot. So the effect is thermal. So that's in the FCC rules. If you stay, so close to the antenna, you get you're supposed to keep the distance because of something called RF burn. Okay, and that's because of the electrical energy. Electrical energy. Okay, and that's something you need to consider here. So understanding what we're talking about, that a Wi-Fi router is at 1 watt. Okay, and again, that's the max you can put on this. I have definitely tried kicking that up a notch using some various techniques, and they're topped out at 1 watt. So some countries their routers are set to a lower level, and you can pump it up to the top level. But and I know how to do that in software, and yet the maximum is 1 watt. Okay, so given this, then you ask yourself, what is the wattage of a transmitter at a cell tower? When you go to a cell tower, what's the wattage of that? Do you actually know? So I actually checked it out, and the answers from yesterday were not quite accurate. So I'm going to tell you the actual wattage of a cell tower. Okay, this transmitter, this tiny little transmitter here, transmitting a very narrow signal, okay, is transmitting between 1 to 8 watts. This thing here. A cell tower, it's transmitting at 40 watts. And that's pretty far away. 40. And actually, it's not 1 at 40. What they do is, in order to not be transmitting too much energy, they actually have it in multiple. So they may have 3 separate devices, 3 separate antennas at the cell tower, and the 3 separate antennas are transmitting. This is for 3G, transmitting at 40 watts. Okay, and you're not nearly near 40 watts. You're not. Yes, if you stick your face to it, yes, but it's up in the tower. Again, damaging, heat damage, which is what we're talking about here. Heat damage from RF, you're normally talking about in the 1,000-watt frequencies. It's not normally an issue at 40 watts. How do we know this? Because amateur radio operators are sending 1,200 watts from their shack, and the antenna is right there. And they're sending, and then it's feeding through the roof. But sometimes the antenna is close by, and they're feeding, 100 watts easily. 100 watts is not that unusual. But sending, 1,200 watts, usually you put that on the roof. Okay, so this is not something unusual. Amateur radio operators are already experiencing these kinds of radiation amounts and wattage. And yes, you can have a burn if you get close to the antenna. And by close to the antenna, I mean close, like that close. That's going to give you a burn. If the antenna is several feet away, you don't actually feel anything. Okay? Again, the effect of the RF at the low is not ionizing. The effect is heat, because you're transferring electricity. It's actually not capable of transferring electricity to you from a great distance, even at 1,200 watts. Okay? if it's a great distance, it's not going to transfer the electricity to you. So now, if this is the case, then here's the crisis that's being talked about. Here's the actual crisis. If millimeter waves are smaller than the waves used in 3G and 4G LTE right now. Okay, I just showed you the example. On the it's called the 70-meter band of ham radio. This is the size of the antenna, so you can understand the wave. This would be a half the size of the. So this would be the actual length. Okay, so double that. Okay, so this will be the size of an antenna for about 440 megahertz, which is what is being reached by this radio, typically. Okay, now if you're going to go with cell signals in 3G, the 3G would be this size antenna. So this is about the size of the wave that's hitting you. There. That'd be about 3G. No, sorry. 3G is here. No, 3G is smaller, like that. Okay, so that's the size of a 3G. Now, when you go to 5G, in theory, then it will be a fraction of this. Okay, so the wavelength of a 3G would be a fraction of this, in the millimeter range. Do you have sure, Jay. Okay, so be a fraction of that. Okay, so now one of the properties of waves, when they're this small is they have a shorter reach. They don't reach as far. So this is the theory that the conspiracy theorists are talking about. They say, well, since millimeter waves have a shorter reach, they can't reach as far. Then the response of the phone companies would be to increase power. So this is the theory that 5G is about increasing power of transmission. So instead of 40 watts, they're saying, well, millimeter waves are shorter, so they need more power. So we're going to be transmitting at 400 watts. Okay, listen to this. This is the main issue to be debunked here. So the people who talk about millimeter waves are saying, and it's true, millimeter waves cannot reach as far, so they think the only solution to the problem is to increase power. Okay? Do you have that so far? So if it in fact is true that we're going to increase power, then we're going to be subjected to an RF frequency at a much higher rate, which could affect us because we don't really know. If they need to go to 400 watts instead of 40 watts, that's a pretty big jump to something we haven't measured. Now, in reality, experience tells us RF energy at that level will just be heat, not cell damage. Heat. Still, it can cause damage because it's like sticking your head in a microwave. It's not, everything is called radiation, but it's not the same kind. It's a non-ionizing radiation. So the only thing emitted in the lower ranges, including microwave, is heat. Okay, so when you cook your food in the microwave, it doesn't come out as a, radiated product with, actually some people were afraid of that. They were saying, what happens when you put your food into the microwave? And you're saying, wow, it's going to cause cancer. I put the food into the microwave. It causes cancer because I bombarded with microwaves. No, the effect of microwaves, which is 2.4 gigahertz in a microwave, the effect of microwave at 1200 watts, which is what a microwave is, 1200 watts, the effect is heat. It penetrates the areas that are conductive to electricity, like water, and the effect is it transfers the energy from the RF into the watery portions of the food, and it translates to heat. It doesn't cause cell damage to the food because you eat it. If it causes cell damage, the food will be different. It would cause, various chemicals to come out of there, right? Okay. So do you understand now that if you're gonna have to, get a true test of the effect of microwave, then you're eating it. You're eating it. If you're able to eat your microwave food, what did you notice that the effects of microwave are? Heat. So if you stay close to any RF frequency, yes, microwave has been safe so far. I mean, I've been using it for a long time, haven't you? Are you dying from it? So whatever you eat if it's being damaged at the cellular level, could cause poisonous effects because you're eating something that's damaged at the cell level to some other product just by radiation. So if you actually just give you an example, if you take your fried chicken, instead of, and you said, I don't want to eat the fried chicken with microwave. I'm going to pass it through. I'm going to pass to ionizing radiation. So I want to eat the fried chicken. I'm going to pass it through gamma rays. And I'm going to eat that. Well, go try it. Okay? Go try eating, gamma rays. Go try eating something with gamma rays. You won't like that. There goes my microwave sales commission. There's no real 5G at Big Kahuna, man. A lot of them are fake 5G. So I'm trying to tell you how it's actually going to work. Anyway, so the thing to be debunked is that they expect that the carriers will send you a higher wattage signal of phone frequencies, and that's why it's going to cause a problem. Well, you can already test that with a microwave. If you put your head in it, it will generate heat. It doesn't cause radiation to happen to the food, and the food is normal after it's heated up. Nothing changes to the food, as you know, when you heat it in the microwave. Yes, we've heard about all that stuff in the past. Your microwave is proof of this. Nothing happens but heat. Right? This is the actual range of the frequencies. If I'm scanning the frequencies, no Tinkerballs, no cancer. This is the actual range of frequencies that you actually see. I'm scanning the spectrum here. This one is in the ham band, 440 megahertz, which is in the reach of my radio here. This is at FM radio, which is actually the most powerful signal. This is the most powerful signal I've seen so far. It's FM radio. You could die from FM radio. It's the strongest signal. The strongest signal is FM radio right there. This one is air traffic control. Very weak signal. Air traffic control. The reason it's weak is it's pointed towards the sky rather than pointed towards us, people. This one is NOAA, the weather station, NOAA announcement. That's a very strong signal as well. Okay, very strong signal. So you can't see the numbers on the left, so I'm telling you strong or weak based on my measurements there on the left of dBm. This is your cell tower. You can see it's actually pretty weak. Look how low it is. This is cell tower traffic coming from 40 watts of transmission from a typical tower. Okay? This is about 40 watts. There, individual phones have a higher signal. Those are individual phones right now. Okay? And they have a higher signal. This is the cell tower. And so you can see cell tower traffic is very, very low RF, actually, even today. So here's the question it's the question that I will raise now. So if that's the case, and you saw the actual level of cell tower today, do they actually have to increase wattage of transmit power for 5G? Do they actually have to increase transmission power of 5G? The answer is no. This is one of the false statements made by many of these people who are conspiracy theorists. Are you conspiracy theorists on this, Wifukan? 5G will be great, but not for. There you go, DJ Murdoch. Okay, so are you conspiracy theorists, Wifukan? So if you're a conspiracy theorist, you're going to say, well, 5G doesn't have much reach, so they have to either one of two things: increase the wattage, or put an antenna every 2 homes. For every 2 homes, we'll have to put an antenna, which is theoretically, that's been the theory that they're saying, that the telephone companies are going to put a cell tower every 2 homes. Okay, well, that's kind of crazy. So that's not how they're going to do it. So the way they're going to do this is not by increasing the power, but through something they invented that has to do with antennas, and it has to do with something called massive MIMO. Why won't they make 5G great for privacy? Okay, so I'm going to introduce you to a new term. It's called massive MIMO. No, they're not going to do that open source. That's not the solution. The solution to making millimeter waves reach everything is called massive MIMO. Okay? Massive MIMO. So what is MIMO? So MIMO is a solution where they let's talk about your current cell antenna. So if you look into the antenna of a cell tower, well, the antenna will be kind of like that. Or to put it in physical terms, it's going to look about like this. That's about the antenna that you will see in 3G and LTE. A little smaller for LTE, but roughly like that. Okay, this is called a dipole antenna. There's two portions to it, half wave, half wave. Okay, this is called a dipole antenna. Okay, and that's normally how it's positioned, like that. This antenna, which you're currently using for 3G, is omnidirectional. So the way this works is that it sends an equal signal all around for receiving and for transmitting equally all around the antenna. That's called omnidirectional. This is how 3G works now. And for LTE, omnidirectional antennas. Okay? So somebody figured out, you all have seen a Yagi antenna, right? Well, here's a Yagi antenna. Okay? So if you haven't seen a Yagi antenna, there's one. So a Yagi antenna is a directional antenna. That's a directional antenna, okay? Now, a Yagi antenna is directional, but the problem with a Yagi antenna for directional is you need a lot of it, A, and second, it's fixed in position. So anytime you want to point it somewhere else, somebody has to climb up the tower and reposition the Yagi antenna. So it's very limited. It's also very large. So what they found out, and this is the theory that I was trying to explain yesterday. So this is 2 parts of an antenna. This is a dipole antenna. So this is the way antennas work, even in cell towers. Let me make it longer just for demonstration, although they're actually pretty small in the cell tower frequencies. Okay, so this is a typical dipole antenna, 2 parts. They're not connected. 2, dipole. If you keep it in its normal configuration, the reception of and transmitting energy of a dipole antenna is an exact circle. It's a sphere. Okay? It's actually a sphere on this side and a sphere on this side. So there's like 2 lobes. Okay? So that's how the current and the reception is equal all around. It's omnidirectional antenna. So what they found out is this, that if you move antennas like this far apart, a wavelength apart, then the antennas get more directional. So it actually starts to point more that way. Okay, and this is the part that's really interesting. They found out that if you have more of these antennas, like 4 of them, instead of having 2 antennas, and you have 4 of these antennas in a row, that it gets more directional even. So it actually creates what is called a beam. Okay, it creates a beam. So they figured out that if you power antennas close to each other at a measured distance, they figure out what the distance is going to be, and they measure that, and they have 4 of these, let's say, and they send the same signal, same power, 40 watts. They send it to these things at the same time. Then what actually happens is the beam becomes a focused beam. The antenna signal becomes focused. So you can actually point like a Yagi antenna. Here's the other thing they figured out, that if you have 4 of them, 5 of them, 6 of them, 8 of them, whatever, depending on how you organize the frequencies, you can actually make the beam change direction, software-wise. Okay? So if you fire up 4 antennas, 3 antennas, 6 antennas, 8 antennas, the beam actually changes direction. This is with the same power at 3G. This is not using any more power. Okay? Because the antennas focus the wave in a certain direction, that one power actually reaches at the same level as 3G. So if you're on millimeter wave, you can, even though you're millimeter wave, which doesn't have as much reach, it will reach just as far if they focus the beam. It'll focus the beam. This is a more technical explanation, which is why it's not as popular. It's a more technical explanation, Kelp, because I actually have graphics and equipment. Okay, so and the other thing about the way that they figured out how to do this is by delaying the signal on one of the antennas by some fraction of a wavelength, called making it out of phase, and they actually can move the beam focus up and down as well. So this is actually how it's going to look. This is actually how it's going to look. So they're going to have a massive Mimo, meaning massive antenna array, and using software, they can make those beams point anywhere they want. Okay, so the plan is, and I'm going to show you what it looks like in real life here. This is show you an example of a 5G antenna right there. That's a 5G antenna. Okay, now you can see that I don't know if this is a live example, but the examples that I've seen show usually 2 antennas in each one of those, and so for every rectangular area, you can say the size of the person on the right. That's typically about 128 antennas for that massive Mimo. Can we VPN those cell tower beams? Okay, so massive Mimo, that's an example of that. That is what 5G is all about. Massive Mimo. So these devices are going to go focus beams by doing the antenna positioning by software. That's how it's going to work. They're not going to increase the signal of the millimeter waves to reach further. They're just going to focus the beam into a beam like the one I showed you here. They're going to use focused beam. Sorry, where did my focused beam go? They're going to focus the beam like that. And that's how they're going to get reach instead of being just a round circle. Okay? So on move. Okay, so that's why that's how they're going to make the beam go further. So In reality, then, think about the cell towers that's going to be in your neighborhood here. Here's an example. Okay, this is a cell tower in the Netherlands, I believe, from T-Mobile. This is where they were testing 5G. That's an example of a massive Mimo. As you can see, the antenna aren't much closer than your normal cell tower. It's still on a zucking cell tower. All they've done is say, let's have focused beams, that way they reach further. That's actually what's going to look like. They're just going to stay in the same, mostly, not always, in the same cell tower. Mostly. There may be areas where they have to put another tower because of the way these beams cannot cross, like if it's not visible, they may have to do some side thing to reach a certain area. So what they're going to do is put several of these things in a circle around a cell tower, and they're going to have beams. Now, here's the problem that you really need to think about. So these beams, like this, are going to be in the hundreds. So think about 400 to 500 to 600 beams, individual beams, pointed to the ground. Yes, Mitch, the world is not ending. Okay, no, the opposite, Mitch. World is not ending from 5G. That's been trying to explain here. Okay, so those beams are what focuses the same amount of energy, but in a narrower. I don't support anything. Mitch, that's the scary part. Yeah, 5G is technically going to be exciting, but the effect on your life will be in the big negative. Okay, so anyway, let me explain now what the issue is. So they're not going to. They may, but in reality, most of the wattage of a cell tower will, at least the one I've seen when they were testing, they're not increasing the wattage transmit power of a cell tower. They're still using the same 40 watts to transmit on a tower, standard tower. Okay? Maybe they're using more than 40 watts when they're out in the boonies, but in a typical area, it's the city, it's about 40 watts, according to somebody who works for some of these carriers. Okay? So 40 watts. So 40 watts is again, it's nothing compared to 1200 watts of your microwave. And again, if you have any problem with microwaves, try cooking your food with it. It's at 2.4 gigahertz, and your food comes out edible. If you have too much wattage of microwaves, what you get is heat. It doesn't seem to ruin the food. So that's what I'm saying is the effect of microwave. Now, here's the real issue now with 5G. So because of the way the technology works, with 5G, the 5G, yes, it will allow car avoidance systems to be online in the internet with online video. That's one of the advantages of 5G, is because the bandwidth's going to be so big, and the signal will have very little interference because there's really nothing in that upper range. So the microwave doesn't kill food nutrients. Well, heat can kill food and nutrients. So whatever heat does, heat will do. So cook it any way you want. Put it under a broiler. It might use up those nutrients, but it's based on heat. So that's a reality you can test every day. So just don't overreact to it, because you're already using microwave. You're already subjecting yourself to RF constantly. You're more concerned about the constant radiation. Then why aren't you concerned about the constant radiation from your Wi-Fi, which is at 5 gigahertz? So I'm sitting next to this at 5 gigahertz constantly. Now this is about a watt. 5 gigahertz constant. Your phone's quarter watt. Your cell phone's quarter watt. Your computer quarter watt. Routers 1 watt. Okay? So if you're concerned about that, then you should be concerned about, about your Wi-Fi. But we already know what the effect of that is. Mitch, some of you are just not paying attention. I said, if you want to test the impact of microwave, it's simple. Put the food into the microwave. Power it up at 1200 watts. What zucking happens? It gets zucking hot. Does the food give you cancer? Does the food turn into something else and give you cancer? What actually happens to the food? Well, we've been using microwave for a heck of a long time. Okay, I don't know when you started using microwave, but I've been using it a long time. Okay, so if you're saying that the microwave can damage you and cause cancer, then why are you using microwaves? You should be concerned about the sun because the sun has ionizing radiation in the higher frequencies. The cancer rates have skyrocketed. That's not actually true. The cancer rates have not skyrocketed. That's actually incorrect. We've been getting cancer for a long time. Yeah, UV is ionizing radiation. So UV and above is known to be ionizing radiation. Okay, so that's a fact. What's your opinion of people? Well, put your head in the microwave. It's going to get hot. Okay, now, so the reason I want to debunk that is I want to focus on the real problem of 5G. Because 5G has a very serious problem, and it has nothing to do with the technology of 5G as it relates to gigabits or radiation or anything like that. That's not real the concern. Okay? The concern is that because 5G is based on beam technology, so you're actually transmitting and receiving on known beams, that each beam will actually be pointed at you. There will be hundreds of beams in a typical tower. So each beam will actually, you're going to connect to a beam. You're not going to connect to a cell tower anymore. You will connect to a beam of the cell tower. You're going to connect to beam 5, beam 77, beam 250, beam 512, beam 64. Okay, now if I'm on a cell phone and the cell company knows that I'm on beam 64, well, they also know where beam 64 is pointed at. Oh, beam 64 is pointed at that house. It's in a cell tower high above, and then plus the reflection. So these beams, as you can see in here, are direction focused. So it'll be like a microcell. So like Omar over there, Ben Omar over there is not just going to be in cell tower A. He's going to be in cell tower A, beam 67, which will be a very small area. Okay, and here's the other thing to know somebody's location. He's getting some signal from beam tower A, beam 64, and with a reflection from beam 42. So he's getting dual signal, a little bit from beam 64, a little bit from beam 62. Well, that's being transmitted to the cell tower, so the cell tower now knows, oh, we know roughly where you are. Because as you connect with your cell, so you're walking around with your cell phone, all over your neighborhood, and it will then connect to some beams by direct beam or some beams by reflection or refraction. So it will actually, somebody can easily track this because they can say, oh, if I walk around, I connect to beam 1 and beam 7. If I walk over there, I connect to beam 7 only. If I walk over there, I connect to beam 64. All of these beams are focused down and they're getting reflection, so the actual area that you're in is going to be very, very noticeable. So currently, when you are, if you're using Hide My Ass, they're going to show all the logs to all the governments which they've done. So there's the problem, folks. With this technology is, can you imagine that you combine with technology? And one of the things that the 5G is supposed to do is make everything video. So there's going to be live video on self-driving cars, live video in buildings. They said that 5G will be 75% video. I want you to understand what I'm talking about here. 5G means 75% of the traffic. This is what AT&T says for them. They expect 75% of the traffic to come from video. No, Jay Colby, that's not what we're talking about. We're talking about facial recognition. We're talking about cars with cameras that are showing their position with live cameras, live everywhere. So there'll be cameras everywhere zipping by you, cars with cameras, buildings with cameras, everything with cameras being fed to the internet and 5G, plus the beamforming that can point to exact location. It's like, what the zuck? Now we're into totally 1984 world. That is a serious consequence of 5G. 5G has a consequence that relates to the world is turning into a online video. We will be an online video with 5G at all times, plus the beamforming. So 5G can try. Yes, that's the scariest part of 5G is that these beams. Forget about the radiation. That's inconsequential here. The radiation is inconsequential. But the fact that the beams will actually, point at your cell phone. Each cell tower will have just hundreds of beams. A single cell tower will have hundreds of beams. So right now, if you go on the phone, you say, where am I on the phone network? Oh, you're sharing the same channel on cell tower A. So all they know is you're in cell tower A. Not anymore. Divide that by 512 little cells. So they will know you are in one divided by 512 of whatever the scope of a current tower is. 1/512 of that. Okay, and they can refocus the beam. So, for example, if they want to make sure they get more reflection of the beam, they can, by software, adjust the beam position. So the beams are not focused by hardware. There's no little motors to turn the beam around. It doesn't work like that anymore. They have found mechanisms through computation how to make beams point anywhere. So if they say, I'm getting a bad signal, then the phone company can say, oh, maybe we'll adjust the beam that way. Maybe we'll move the beam this way. Okay, so all the beams will be pointed down. With 5G, every car will have video. With 5G, every car, self-driving car, will have a video, and it will see the environment. Plus, with the location here with these beams, oh my gosh, it's like instant surveillance. Oh my gosh, I mean, do they even need? Will they even need individual cameras? You know how in the UK there's a camera in every street corner? They won't even need that. They'll just be the amount of cameras circulating video on the internet will be massive. And they'll be transmitting the signal on the internet, and computers will analyze the video to see real time with learning what they are seeing in the environment, and reacting to the environment with learning massive learning capability as they're passing the video to the big servers at the Googles and the Facebooks. This is a very, very scary proposition, and it's if you actually understand the effects of what I'm talking about, it's a much more serious issue than saying, oh, this is really about radiation. See, that's a distraction now. Now we're thinking, oh, this is radiation and we're going to go die from it. Well, sorry. I just don't buy that, because if you're eating your food in a microwave, then hello, Simon Pickup. Do you use your microwave, Simon Pickup? Do they use microwaves in the UK, Simon Pickup? Have they been using microwaves since the 70s in the UK? Yes or no? That's why I'm applying tinfoil to my truck. I will be invisible. So you never use a microwave. You're ignoring YouTube comments again. Face gate arrays. I'm ignoring all comments, Simon, when I'm talking. So all comments are being ignored when I'm trying to explain something deep. Okay. So no, face gate arrays. No. Face gate phasing allows the antenna to be. I actually watched the physics of this. There was a physics video that explained this. Okay, this is the logic of beam forming. Let me move this picture here. Okay, this is the logic of beam forming. I'm a level 4 vegan. Okay, this is a typical dipole antenna. So two separate, half wave antennas that's a dipole. This is omnidirectional. So if you increase the distance between the two antennas to about a half wave and then to a wavelength, then the signal becomes focused. So there's a node that bulges out. It becomes directional. If you have 4 of these, it becomes even more directional. So you can actually, with 8 of these, or such, you just have a very directional antenna. Now, if you do that and you power up and send a signal to, let's say, 8 antennas or 16 antennas or whatever, what will happen is that the beam will be very, very focused. The beam will be very focused, just like as shown in this photo here. That's how that works. Okay, by firing up the same signal over several antennas at the same time, then you get focused beams. Now, what they do to change the direction of the beam, and this is the part that's interesting, is you can change the direction of the beam so that instead of just pointing in a fixed direction, you can point it up, down, left, right. You can do that by changing the phase of each signal to each antenna, meaning timing. So if you delay the signal to one of the antennas a little bit, it actually shifts the angle of the antenna. So let's say and this is done within a fraction of a wavelength, so just to give you an idea of phase. So it's not something you'll notice. So if you're talking, it's not going to go give you an echo or anything. It's too short. Okay, but it's enough to adjust the antenna focus. That's how to adjust this with sending a phased signal to the big antennas. This technology is called massive Mimo. Simon, not phase gate arrays. This is called massive Mimo, which combines all of this technology. That's a term for this. This is the 5G term. This is what makes the signal reach further. By forming into beams, they reach further away. So they can stay in the same cell tower and reach further away by using something called massive Mimo. Okay? But that same technology, again, that focuses the beam means we're now going to be living in a microcell environment. So a cell tower is not just one tower. It's actually divided into microcells based on the beam. So a typical cell tower may have 500 antennas, 512 antennas. And they can make any combination of beams by switching them back and forth and phasing signals in between, maybe overlapping signals with different phases and so on. And so they can actually create a lot of signal traffic in that and then have the beams focused. The upside is it just that got much harder for terrorists. Oh, yeah. What did you say yesterday, Kelp? Kelp said yesterday that the best way to hide Stuff. Sorry, Kelp. It's the stupidest argument I've ever heard. The best way to hide is to hide in plain sight. That's really stupid. Sorry, Kelp. I don't mean to call you bad names, but it's so stupid. I don't know what you want to say. Okay. The best way to hide is actually disinformation. If you want to not hide, disinformation is better than plain sight. Why is plain sight any better? Is Temp-Break legit or have I been hacked? No, Simon, it's legit. I don't want to rush working on these. It's work for the best. In what way has it worked, Kelp? Somebody has collected all of your data now and is selling it? So Kelp is saying that I'm hiding in plain sight because Axiom, Intellius, and Spokio have all of my information and all my social media and are selling that information, including my locations, to third parties. And I'm hiding in plain sight. This is perfect. That's so stupid. Who do you think the opposition is? Who are you hiding from that you're hiding in plain sight? Who do you think the opposition is? Now, if you think the opposition is just the government, then you're zucked up because the government is one little portion of the opposition. The opposition is private parties buying and selling your information and figuring out how to manipulate you with that information and say, I'm hiding in plain sight. Okay, as you watch the tenor of your timeline on Facebook change, you're saying, I'm hiding in plain sight. Yes, they're manipulating you by sending you information that fits your profile based on what they know about you. I'm hiding in plain sight. Oh, it's really smart. Smart move. Okay, so anyway, this is what 5G is about, really. It's not about increasing the signal. In order for 5G to send you the signal properly without having to increase the strength of the transmission power, it's just going to do it by making the signal more efficient. And efficiency is acquired by, instead of sending a small circle of a omnidirectional signal, that by focusing the beam, they don't need to use as much energy. Well, Kelp, don't say stupid things. Come on. Okay. So maybe unrelated, but will 5G carrier plans be priced on speed or amount of data use? They will try to make as much money as they can, Damon. But then the price will go down eventually. I'd rather walk through an incandescent light than a laser, though. Focus can't be ignored completely. Well, if you're walking in front of a laser light, that could be a laser dot from a gun. So I am worried about laser lights. If I see a laser light, I'm going to say, is somebody pointing a gun at me? So, yeah, that's going to worry me. YouTube comments no longer popping on screen. Oh, did I do that? Sorry. Did I block the YouTube chat? Is it covered by the... One day maybe we'll bump into each other hiding from Walmart and Amazon's drones. You don't need to hide from Amazon and Walmart's drones. So it's ineffective ways of doing spying. 5G will be better at spying. What is La Llorona? If you can tell me what that is, then I can tell you I'm probably not afraid of it. Yes, and power matters too. Yes, I ask you, Simon. I asked you the question, Simon. Do you use microwaves in the UK? Being laced is not a good feeling. Duck and cover. Do you use microwaves in the UK? Yeah, so if you're using microwaves in the UK and you're eating it, there's your effect of microwaves at high power, 1200 watts. It will cook you. So if you're standing next to something that's cooking you, you're probably going to feel it. So you can say, it's kind of getting hot in here. I probably need to move away from whatever's generating the heat next to me. Right? If you have your 5 gigahertz Wi-Fi next to you, and suddenly you feel like you're getting hot, maybe it's a 5 gigahertz Wi-Fi. You don't even sunbathe. So I don't put my head in the microwave, though. Yes, the point is you put your food in it and it's cooked. And if you think it's going to cause cancer, then why isn't your food causing you cancer? Because it's the same living tissue, and you're putting it in a sucking microwave. That's no different than what's going to happen if you put your body in there. So it's not going to give you cancer. It's going to give you hot food. Okay? So, put whatever you want in the microwave. It will absorb the electrical energy. Microwave food does cause cancer. Well, why are we still using microwaves then, Tinker? In the 50 years we've been using microwave. In the 50 years we've been using microwave, are you saying that somebody's coming out and say this actually causes cancer? We need to stop it. So in California, if something causes cancer, they put a sign on it that says this causes cancer. Tinker, in California, when you have anything, in fact, everything in California causes cancer, you see a sign. Using this TV set causes cancer. Using this causes cancer. Using this whatever causes cancer. But I've never seen a sign on the microwave that said this causes cancer. Yes, there's a sign that says smoking causes cancer, but I've never seen a sign in California that says, it's a law. It's a law. In California, if it causes cancer, you will get sued if you don't put a notice that says this causes cancer. You mentioned your piano is tuned at 440. Have you any tuning on 432? I do not do that kind of tuning, Damon, because I'm playing with a band. People sometimes change tuning for effect in classical piano. That has nothing to do with me. So everything I do has to match other instruments. So we all have to tune at 440. Living in California causes no entire Meyer. In California, there's a law that says if whatever it is that causes cancer in any quantity, then for example, motor oil causes cancer. They say. So if you buy motor oil from the gas station, you'll say this product causes cancer. Well, I'm not going to eat the sucking motor oil. Still, by law, they have to do it. Okay, but there is no warning on the microwave that says microwave causes cancer. So if so, then who's actually proven that microwave causes cancer? Microwave causes heat. So microwaves, which is the same general area as cell signals, is going to generate heat. Johnson's baby powder causes cancer. Yeah, here in California, everything. Paint, foods, smoke, whatever. All of that causes cancer. It's strangely none on a microwave. So, anyway, I don't microwave motor oil. You could try. Hello, Patch the First. You could try. Nonsensical. Most people know cause cancer gets smoke. Yes. Warning for warming for baby powder. Well, don't use baby powder then. What does that have to do with radiation? We're talking radiation here. Patch the First. Entire Myers making a joke. So anyway, but I'm just trying to educate you on some of these. The 5G world will actually be quite different. And again, the 5G world has to do with the effects on video. Our whole lives will be on video. It'll be like what's in that movie with where everything is on video. That is the technology of 5G. It's really nothing to do with radiation. Forget about radiation. That's the least of your issues. Okay? Everybody's focused on the radiation, which is like, as far as I'm concerned, that is unimportant. You have more to fear from the sun. Worry about the sun first. then we'll worry about the radiation from 5G later. Worry about the sun first. Stay away from the sun. You can say, well, I go sunbathing, but I'm really worried about 5G. It's like, suck. Truman Show, yes. Yes, Truman Show, Marie, yes. So seriously, you can't ignore directionally focused beam. 1 watt beam is worse than omnidirectional 1 watt. Well, Simon, what the thing about a millimeter band is they're weaker. In effect, they're easily blocked. You can as you go higher up the spectrum, you can block them with a piece of paper. Since they're actually easily blocked, they're actually a weaker signal. So the moment you go to a higher frequency, the signal gets weaker. But instead of increasing the wattage, they just focus the beam, so the signal strength is the same as it was on the lower frequency. When will Trump be? What? But bandwidth, you can't ignore directional. But seriously, yeah. So anyway, directionality has to do with the same force. So what they're saying is, okay, let me try to explain this a little bit more clearly. Comparing 3G and 4G. So this is the effect of frequency. So let's say that's the length of a signal. This is the length of a signal. Or let's say that's the strength of a signal. If we're going to talk in, range. Let's say this is the range of signal of a 3G. Okay, and let's say that this is the range of a signal of millimeter waves, 5G. So as you can see, they don't reach as far because they're weaker. That's a natural force with higher frequencies. They don't reach as far. They're easily blocked. Objects, rain, all that blocks that range of frequency. So, yes, how do you make them just reach that? Well, you can increase the power. So this would mean you have to double the power twice. So that, see that, about 6 dB. You have to twice doubling the energy twice to match this in this example. Okay, that's a lot of energy. So if you're doing 40 watts, in order to match the energy, you have to do 40 plus 40, 80, 160 watts. So if this is at 40 watts, in order for this to reach that same size, you have to send this at 160 watts. As an example, I'm just giving it theoretical here. Okay, you can see how much power you need. I mean, it's 40 watts, 160 watts, but they're not doing that. Instead, they're saying, let's keep it at the same 40 watts, but let's make the beam directional so you're still getting the same strength. So going back to this little chart here, and again, I want to show you this video. Okay, if you watch this video of actual frequencies, hold on, let me just hide this other one here. Okay, that's at 446 megahertz. So you can see the signal strength in there. I'm trying to keep the strength relative, so they're about the same. This is the signal strength at 40 megahertz. This is an FM radio station, very powerful. This is the most powerful signal around us, around me. And this is a low energy FM station, and it's still the most powerful signal around me. There's air traffic control, very small signal, very weak. Air traffic control is weak because the signal is focused at the sky. It's not focused on the ground. So I am not seeing much focus on, because it's directional. This is from the weather station NOAA, and that's very strong. That's one of the stronger signal. Okay, that's a very strong signal there. So in terms of signal strength, that's very strong. Okay, that's from NOAA. And then this is the signal strength from cell towers. Very low. That is the signal strength from cell tower. It's in amplitude, it doesn't even, it's very low. It's like quarter strength. in dB. That's many multiples lower. And that's the cell tower. That's the signal of our cell phone from cell phones nearby. That's even stronger than the cell tower. And that's transmitting at a quarter watt, but it's close by. Okay, so you're seeing there a comparison of the kind of forces we're talking about. It's actually kind of low. I can check the frequencies of anything. Okay, this is my own equipment to check for frequencies around me, and you can see that. Okay, so I just want to make sure that you understand the comparison. I'm using actual data from my own devices. I can see what the frequencies are around me. I can check all the frequencies all the way to 6 gigahertz. So we're probably more affected by Wi-Fi because Wi-Fi is so close. Now, some change is going to happen to Wi-Fi. Now, I didn't mention this earlier, but this is a change that's going to happen to Wi-Fi. At some point, hello, Claire Peters. At some point, Wi-Fi will also get Mimo. Maybe not massive Mimo, but Mimo, meaning directional beams. So at some point, this is one of the ways they're going to make Wi-Fi more powerful, is to have where did my beam go? Beam, yeah. So at some point, even your Wi-Fi may get this, and this may be the next advance in Wi-Fi, keeping the same frequency, but using beam-focused Wi-Fi. So this is what I project is changing the way Wi-Fi points the signal with beam technology, using the same frequency. Okay, so that's what I predict will happen. So they're probably going to sell, devices like that to use this technology. What is the best software to detect the spectrum? Yes. Well, I have a high end here. If you want to detect, depends. If you want to go for something cheap, like $30, you can get something called RTL-SDR. RTL-SDR. It sells for $30 at Amazon, and it's a receiver only, and it can check for signals all the way up to, I believe, 1.2 gigahertz. So it doesn't reach the Wi-Fi range. 1.2 gigahertz. It can reach all of that. Okay, so that's the range of a RTL SDR. Now this is a much more sophisticated device. This is actually a full transceiver. This goes in range all the way up to 6 gigahertz. And this has a transceiver capability. So you can actually use it to jam signals, run your own cell tower, testing cell tower, use it for opening your garage door, opening your car. A lot of hacking things you can do with this. This is a pretty nifty device if you know how to program this. Very interesting device. So this is exciting. I just got this. And it's exciting what I'm able to do this, with this device. Anyway, I have a ham license, so I'm allowed to do it anyway. Some Wi-Fi routers already have MIMO. Yeah, but they have like 4 antenna MIMO, not the beam-forming MIMO. Okay. Simon, if you see a Wi-Fi with 4 to 6 antennas, that's already doing some version of MIMO, but the antennas are manually done. So that doesn't really, you don't know what you're doing with that. So software directed MIMO is what I'm talking about, where you focus the beam by software. That's the kind of stuff I'm talking about, where you can actually maybe look at some app and say, let me point the beam over to that door over there because you don't seem to get internet over there. So I'm going to point my Wi-Fi over there, and at the same frequency. and that will increase the signal and reach of 5 gigahertz, which is a very short range. So I'm thinking somebody will come up with that. If I can't, if it can't, I guess it can't read direction. It does know where the antennas are. Uh, it doesn't help to physically point the antenna because the computation for the beam requires another piece of equipment to check for directionality. You need some special equipment to see where the beam is focused at. How are you going to know that? You have to study the math of it. There's mathematics involved, and none of us know how to do that. We're not physicists. You don't need gas. Badge. What's up, Badge? What's up, Badge? So anyway, that's gonna be interesting when they do that technology because you can actually increase the sensitivity of your Wi-Fi without having to occupy any new frequencies. Because we kind of have a frequency problem here. Wi-Fi is in a very narrow frequency range. So do Wi-Fi need to go to 28 gigahertz? Probably not. Yes, Badge. So anyway, that's I learned that at that antenna combining stuff to electronic, but I've forgotten. Yeah, but I watched a lot of the videos explaining all that. I'm not an electrical engineer, but I'm a software engineer, and I'm looking at I get it. I get the physics of it, and having a ham license helps because they understand, what is needed. If you have a ham license, then you have to understand the frequencies because that's why you have a ham license. Okay, so the idea of massive MIMO, which is the focused beams that we're talking about, that's focused not by hardware but by software. A combination of which antennas you use and how far apart they are, combined with phasing the signal. So timing phase combined with which antennas changes the direction. So you can actually micro focus an antenna by software and say, I'm going to send a signal to that door, or to the roof, or to the whatever floor you want. Now, the final point about this, and this is where 5G becomes really invasive, is that 5G does not go through the UV coating of buildings. So many buildings, office buildings, are not going to receive 5G inside. Okay? So many buildings are not going to get 5G inside the building. So they're going to have to use something along the lines of fem-to-cell, meaning they're going to give you a little Wi-Fi-like device inside the building, which sends the information to the internet. So some of this will be combined with giving you standalone units that can act almost like Wi-Fi stations. Okay? Does Walmart have repeaters yet? I read telephone poles. See that it's just an example of some of the theoreticals that you always hear. That's not the way it's going to work. So forget all that. That's why the conspiracy theorists are using that. They say, well, they're going to put the antenna transmitting 40 watts at every single ducking telephone pole. That is not how it's going to work. It's going to work with a cell tower like this, just using beamform antennas. Not on an every. That's too expensive. That's it. Beamforming. No, hey, that is the conspiracy theory. It's going to be done by beamforming. Beamforming. It's going to be done. All those were, a lot of those things that you read were actually written in 2012 when they were thinking about 5G in 2012. That's not the technology that they're going to be using. Wall Street Conspiracy Journal. Yes, check the year of the article. Check the year of the article. So this is the way it's going to be done today. Okay, millimeter waves will be handled by, well, whoever did the tech of that is zucked up. Okay, it's going to be done by millimeter waves, beamforming. Okay, millimeter waves, beamforming. That's how they're. I've seen the actual test. There are videos of them, the actual test done by Verizon and so on, and they're using the same power. And they're putting the devices in the same cell towers. And they're getting speeds of about a gigabit per second. So that's the speed they're looking at, a gigabit per second. Okay? So anyway, I don't want to have to keep repeating about the microwaves because, you know, if you are afraid of microwave, then you shouldn't be cooked. Incredibly hackable. That's it's more than you think. Hey, because a lot of the traffic will actually go through the internet now. Can you repeat about the white microwave? Okay, I have a whole lot of tinfoil. Okay, again, the signal of a microwave is the same as your 2.4 gigahertz Wi-Fi. 2.4 gigahertz Wi-Fi. This is 5 gigahertz Wi-Fi. What I have here is, oops, sorry, let me get rid of this. Okay, this is 5 gigahertz Wi-Fi. So 2.4 gigahertz Wi-Fi you already have. So if you're next to it and you're dying, tell me. Okay, so you're already using the same signal as the microwave. So microwave is sending 1200 watts of 2.4 gigahertz. Well, your Wi-Fi is sending 1 watt at 2.4 gigahertz, same gigahertz range. So given that, and you're sending it in such power, 1200 watts, and you think it's going to cause cancer, if you put a living tissue in front of a microwave, then why are you eating it? Why are you eating the food that comes from the microwave? Because in theory, if it is going to damage tissue and leave ionizing radiation, which it does not do, then you cannot eat the food in the microwave. But because this is the reality, we're already known for, 50 years of using microwaves, okay, or 40 years of using microwaves, that we already know that microwaves only produce heat. It doesn't damage the food other than by heat. It doesn't change the nature of the food other than if you heated it up some other way. Because all it does is excites the water and takes the energy from the waves at 1200 watts and transfers the energy into the food. Because it's electrical current. Okay, here's the funny part. This is the other part. Oh, I missed that. Thank you, Kelp, for reminding me. This is another conspiracy theory, okay? This is it's the other conspiracy theory. They said that there are studies in the year 2000 that says cell phones are used 30 minutes a day over your head like this, and they said it did not cause cancer. Okay? So cell phones 30 minutes a day did not cause cancer. So the conspiracy theorists are saying, Zuck, that is incorrect info. Why? Because we use the phone more today than we did in the year 2000. That's what the conspiracy theories say. Well, I don't know about you, but I hardly ever use my phone. I use texting. So I'm actually never putting this next to my head. It's actually down here. As you can see, every kid that you know, every millennial that you know is using the phone down here, not up here. Okay? So tell me that it's changed. Okay? So Babe Ruth Day. So, okay, so I don't hardly use my phone like that. I do the down here. Probably the same distance as a computer. I mean, I put my computer, on my lap and it's this close to my face. I probably get more radiation from the computer. So there should be hand cancer. That's correct, help. Yeah, because we're always, there should be finger cancer because we're touching the screen. So come on, people. Come on. It's like, some of this common sense. Common sense. And since you're putting this next to your, next in your pocket and it's radiating, a quarter watt, then nobody should be having babies anymore. It's stored in your pocket. You're still getting babies. The population that everyone in we should measure in India. There are less people being born in India and China because they put the phones in their pockets. Again, understand that this frequency causes heat. Does it, Great Gold? I don't do weed, so I don't know. Yeah, I know. No one's ever claimed they got cancer from weed, yes. But what do I know? I don't do weed. I can sacrifice a finger every 10 years and still be okay. Yeah, how many finger cancer cases do they have? I mean, especially me. I'm on a computer, all day, touching the, radiation coming from the computer. And I still have all my fingers. So I don't know. I'm some of these conspiracy theories do not make any sense. It just does not. I'll be honest with you. They don't make any sense. What does make sense is a surveillance culture that's going to be embedded with 5G. That is going to be big. Yes, hey, I just said that. You don't want my finger. I didn't know that the finger cancer is infectious. Sunlight generates heat and cancer. That's correct, Mr. Jim. Because that's part of ionizing radiation. So the sun is your worst enemy. Because it's in a higher bandwidth. So sun generates frequencies in the higher spectrum, which is on the right there of the visible light. So visible light is that rainbow. That narrow range there is visible light, and to the right of it is ultraviolet, and that's what causes the damage. Anything to the right of visible light causes damage. Anything below visible light generates heat. I don't have any thoughts, Damon. In case you didn't know, wireless headphones use 2.4 gigahertz. Okay? 2.4 gigahertz is the same as your Wi-Fi and Bluetooth. So put your head next to your Bluetooth and see if you die from that. I don't know, Kelp. I don't know if people are getting in here. So, because there's a true danger to 5G, but we're totally getting distracted by thinking of the danger as it relates to radiation, when it's the danger is really to a surveillance world. It's a surveillance. The bandwidth means we're worried about facial recognition, or we're not going to be worried about it. It's going to be video, live video constantly. Everything will be live video. Live video. That's what 5G means. Live video constantly. Internet available live video. By the way, let me just talk to you a little bit about this. This is a ham radio.
Channel mode.
I don't know if anybody's broadcasting at this hour of night.
Scanning begin.
They're wrong, but it was good nonetheless.
So I'm listening to ham radio, right? Checking repeaters. Okay, now let me just tell you about ham radio. The strange thing about ham radio is that you actually have to identify yourself every time you transmit, and so you can't really be, to get a license for ham radio, you have to announce who you are. You have to announce who you are. So you're announcing your call ID, and then they can go check the FCC database and know exactly who you are. Okay? So, and I noticed that a lot of people who use ham radios are very privacy-focused people. And so now here comes the question, and I'm just going to theorize with you for a moment here. Why is this less safe because you're actually announcing your ham radio? You have to identify yourself. You do not have to identify yourself on CB. On CB, you just use the handle. I'm what's your handle over here? So KC. This is KC. Okay, on CB radio, you just have a handle. That's good enough. On ham radio, you can't do that. You got to use your licensed call sign. So you're identified. So it's not a secret who you are because they can go check every time you speak on this. They can go, check the database and see who you are. But there's a difference between this, which is quite open. This is what, as Kelp said, this is hiding in plain sight. This is actually hiding in plain sight. Here's the difference. No one is keeping this in a Zucking database. I don't know if you understand that. Although this identifies you, there's no big database of this. There's no, I can't go to Spokeo and Telus or Axiom and say, such and such spoke for 10 seconds and this is the transcript. There's no encryption allowed for normal people on ham radio. We're not allowed to encrypt anything in ham radio. Great Gold, Alpha Bravo Charlie Delta Echo Foxtrot Golf Hotel India Juliet Kilo Lima Mike November Oscar Papa Quebec Roger Sierra Tango Uniform Victor Whiskey Yankee Zulu. Yes, DJ Murdoch. QRZ.com. Yes. So the thing is that although they can identify you every time they speak, no one's actually making a log. There's no 10-4 on. They don't do 10-4 on ham radio night. That's CB. Okay. Any ship-to-ship communication stuff? I do ship-to-ship. Yes, I have VHF on my boat, which is a different kind of radio. Yeah, I do VHF. So it's not like someone is logging it. No, they can't log it because it's not like that. There's no Facebook logging it. No breaker. Yes, no breaker, Mario. But I could talk to somebody from the other part of the world with not this, but a bigger version of this. I can talk to someone in a different part of the world, and because it's not aggregated data. Do you talk to the local Coast Guard? You can't talk to the local Coast Guard on VHF. Yes, that's very common, especially if you need emergency help. When I'm on the high seas there, you do talk to the Coast Guard. Yes. Kind of like Periscope then. No, Periscope tracks you. That's on the internet. This is different because there's no aggregation of data. There's no egg drop. There's nobody aggregating data. There's no central Periscope keeping the data. It's one person to one person. Do you have a large tower? No, in most ham radio guys use repeaters. So you talk to the repeater then scatters the signal for 50, 80 miles, and you don't have to worry about that. So you just go to repeater. Yeah, maybe, hey, yeah. But I'm researching I'm just busy with a problem on Braxat Me right now, but I wanted to talk about perhaps doing email by ham radio. I'm sure Google are secretly storing ham radio transcripts. Oh, gosh. That's funny. From microwave my ham database is enough, I'll be bacon. It'll be bacon. So anyway, that's a difference with this kind of communication. Even though it actually identifies you, it's a lot safer. So you guys want to learn about ham radios? Just you understand what this is all about? I can teach you a little bit what this is all. Hello, Rankin. If anybody's interested. If nobody's interested, I won't talk about it. Is everybody interested to know exactly what ham radio is? And how, you can talk to people and not worry so much as you would. No, this is not a police scanner. You can actually talk to anyone. D-Star, they could track you because it's software based. No, you could probably hide D-Star. This is a 2 meter band and 70 centimeter band. So it has two ranges, 2 meter and 70 centimeter. I know, Jay, but no one's aggregating the data. That's why it's very simple. No Morse code, no. I don't know any Zucking Morse code. Yeah, limited. Yeah, they do better than phone, though. Again, there's no tracking of this. This is not the spy brick. This is a spy brick. This is not a spy brick. No one's aggregating this data. This is a spy brick. Teach me, DJ, because I don't know Morse code. I was going to use a computer to do the Morse code. You can actually just use a computer to do the Morse code for you. Just type it up and it'll Morse code it for you. Nobody needs to learn the Morse code. You can actually computerize that. So anybody interested in this topic and how we can use this for privacy? Back in the day, Mario, yeah, they changed that. Quite a few years ago. Yeah, you don't need Morse code anymore. People with boats know Morse code? No, we use VHF and we talk with our mouth. Because you're like driving the boat, and the last thing you need to do is say, deep, deep, deep. You don't have time for that. You don't have time for dit, 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 dit. Is that SOS? You don't have time for that. No time for that. But this is 80 years ago, yes. Anyway, I want to talk about this. I don't know when I can talk about it because of my schedule, but DJ's giving me could hit an iceberg. But I'd like to talk about ham radios in terms of the effect on privacy and what, how different this kind of communication is. I've been doing a lot of work with radio frequency. Later on, I'm going to do some videos related to this. This is a very interesting device because I can show you, just demonstrate hacking things, how you can jam signals with this, make a cell tower. Some of the things I was going to do this weekend, but I couldn't because I had to deal with a Brax problem. So, but this is something, this device, this is a Blade RF Micro. Blade RF Micro. You don't need a ham base station, Mario. They sell them this now. You can buy them for $25. Baofengs. Every ham radio guy has one of these. Baofengs. $25. Unfortunately, jamming is illegal. Don't worry, hey, I'm not going to go jam anyone. $25. No more expensive sucking thing. Baofeng. Everybody has this Chinese radio. Pretty good radio actually. $25. Jazz jam legal. Yeah, jamming in music is legal, but jamming with this is illegal. However, I'm interested only in studying the characteristics of it. I'm only studying it in terms of a short range, like laboratory conditions. And say ingest phone calls. Why wouldn't they have receiver and ingest ham too? You really think they would have ingest every single sucking frequency, Simon? That they'd have to put one in every single location. Because how do they know where you're located? Because your address on the FCC database is just could be a post office box. Nobody uses CB radio. I had CB radios. Who uses CB radio? Great hair guy. That's like, nobody uses that anymore. Is there still, what happened to your RF detector? I just showed you the RF detector. So this is the RF detector. You still have one? I threw mine away somewhere. I'm not going to go install it on the car. But this is a RF detector. This one is measuring this is 70 millimeter band. Those are the ham radio. Nobody's near you on CB radio. Nobody uses CB radio. This is FM radio. That's FM. I'll just show you, what my spectrum analyzer shows. So this is air traffic control. That's those little pinpoint signals are air traffic control. The cheapest one is called RTL SDR, DJ Murdoch. RTL SDR is the cheapest. So this one is NOAA, weather, right there. And then the next one, I believe, that's cell tower. That's your cell tower, 3G. Okay, so that's a device I use. And that's a device, RTL SDR, cheap, $30. This is expensive. This is a transceiver. This is not a receiver alone. This is has 2 transmitters and 2 receivers. So that's a very sophisticated device. Now you can actually attach it to a Raspberry Pi and make a cell tower. So these two will make a cell tower. Yeah, Blade RF. This one is an even more expensive model. This is a Blade RF Micro, and this goes all the way to 6 gigahertz with transmit receive. So this is one of the newer ones. This brand new. I think they only released it in a few months ago. Yeah, you can make a cell tower with this. You can also make a Stingray with this. So now you'd need a big antenna and an amplifier to actually make the signal strong, but this is enough. Can you get police radio with Blade RF? You can get police radio with RTL SDR. Stingray's legal though. Yes, but people are using them illegally. Hey. So yes, Stingrays are, the government's using it. Now I'm only doing research. I just want to understand, how it works in reality, so we know how to protect ourselves. So I'm a white hat hacker trying to figure out how to solve these problems. And I'm going to do a lot of videos on this. So that frequency thing is important because it shows you, I'll probably post that on YouTube. I'll make a better one and then post it on YouTube with showing the frequencies so you can actually see the scanning that I'm actually doing. So it's not theoretical to say I'm scanning frequencies and I know what the signal strength is, because I can show you the signal strength. So if you're going to be afraid of something like this, then you should see what it looks like. Let's not be theoretical. Let's see. Have you actually seen what it looks like in real life? Right? You actually need to understand what frequencies are around you. So that's what I'm doing now. Problems aren't just on the internet. RTL SDR is not a specific chip. Yeah, $30. Yeah, it's a specific chip. You can buy it on Amazon. You have to buy with a specific tuner, but the best place to learn about this is rtlsdr.com. So yeah, so this signal was taken from an RTL SDR because I didn't have this plugged in. Is it bad for health? No. I don't think so. Okay. They can do truckers. They can do voice or voice print, ingest, and worry about what to do with it later. Yeah, what I'm talking about, Simon, is there's no infrastructure for collecting voice to receive signals like that in the entire spectrum of the United States borders. You have to put a listening device, a radio listening device, more than cell towers. That's kind of, there's no infrastructure for that, whereas the infrastructure for the internet already exists. So for that reason, this does not, at the moment, this is not an aggregated piece of data. Okay, no one's aware of it being aggregated. Snowden didn't mention it being aggregated, so we're going to assume that's not part of the equation. This is not one of the things that Snowden said exists. So if we're going to base it on that, we're going to say, okay, this is not one of the things that they spent a lot of money on to spy on, because it's not as useful as some of the other techniques that they have on the internet. Facebook is a much better way of spotting you than this. So in that respect, then I don't think, at the moment, I think this is free and clear. So I want to talk about that, as a way of communicating. Instead of 5G, let's find some alternative ways of communicating. Snowden didn't know all. Kelp, I made a video that I created the video link on my YouTube page just for you to watch, and you still didn't watch it. I told you to watch it, and you tell me that Snowden didn't know. Okay? Yes, Simon, Snowden was a few years ago, but you're telling me that they built out this infrastructure that requires millions of devices to track and listen in the entire country? Do you have tried to get weather radar on RTL SDR? You have to get satellite. Believe you can do that, yeah. Yeah, there's instructions for that, yes. I haven't tried it myself. There's software for it. You can get satellite data for weather, and it only passes so many times a day. So it's not something that you can run continuously. It's the satellite data is just a few spot. I tried but failed. I'm hearing a lot of people who had some interesting to say about him. Kelp, in the know in your law enforcement community, they will build it now that you mentioned it. That's why, Simon, I'm actually imagining a new way where you know how a VPN can obscure your traffic location, where you're coming from, well, you can send email through ham radio. So if you send your traffic through a gateway using email that you can reach through a system of relays, then by the time it gets there, there's no way to know where it came from. I am going to be studying that. I was going to spend that time studying it this weekend. I did not get a chance. Yes, Great Gold, you can send email through ham radio. Yes. It's slow, obviously, but who cares? It's like 1,200 baud. But why does it matter? You just click send and it goes. However long it gets there, it'll get there. Right? And mostly it's text anyway, so it's going to get there fast. So, so 1,200 baud. So it will take a while. But again, you're starting to wonder, well, yeah, but at least they can't trace it. So I'm going to be researching that, okay? Hamtor. I can put some servers and then route the servers to a couple of gateways. 900 baud used to be fast. That's slow dial-up. Yeah, but this for email only. So number station. So anyway, that's an interesting thing that you can do because they do allow that. So you send email, you can route email from any place, like a boat out on the ocean, and you route it through ham radio, and you send it long distance to somebody in, somebody across the continent, and then have the email gateway there. You can put SDR online and people can control it. That's true, DJ. When are the sailing scopes starting? I don't know. Maybe next Wednesday. What's the name of the YouTube you want me to watch? The link is on my channel. Go to my channel. Go to the tab that says Community, and it's right on there. Somebody even made a special picture just for you, Kelp. You're famous on the YouTube channel, and you don't go there, so you don't see it. So go there, and then look at the commentary about you, but specifically click on the video and watch it. And then you tell me that well, just watch it. You can give your opinion later on. Yeah. So yeah, you can say I don't care. Well, it doesn't matter. Just watch it. Just watch it. It's a Vice documentary. Yes. Just watch it and then tell me, if it's useless. Okay, fine. If it's useless after seeing that, then I'll say, Zuck you. I'm looking at it now. You can spell the ELP part. No, it was the name that should not be mentioned. That's all I'll say. Okay, so yes, so I will research this more. I don't know if I can do it tomorrow, but I'll definitely because I'm dealing with an emergency right now. So let me get back to my emergency, and I shouldn't be online here. I need to be fixing my emergency on Brax.me. So Brax.me is only semi-running, but you used my face. I didn't make it. I didn't make that, Kelp. Brax is down right now. I have to update the servers to a new version, and that leads to so much complexity because there's a lot of encryption and things in there. So I have to upgrade the servers, everything, new servers, new PHP, all the software has to be updated. And there's incompatibilities when I do that. It only happened this morning. Basically, the certificates expired. Nobody can get in. So I made a temporary link to it. It's not a full running version, but enough for us to talk. And that's the link right. So if you go to Brax.me, it will be a link, and it'll link to the temporary server, so then I can work on it. Okay. So I'm going to be hard to work on that tonight and then tomorrow. And I don't know if I'm going to get it done tomorrow. It may be Monday before I'm done. Thank you, DJ. You're awesome. You're awesome, buddy. Okay, so I'm no longer active and I'm being linked. It's no longer active and being blamed. No, Kelp, the link is active. Click on it again. I updated the link. No, people were commenting that the link was wrong because I had a typo, and then I reposted the link. Okay? Zakia, what's up, my friend? Thank you for watching on YouTube. Okay, so lots of information today, and hopefully that's enough information on 5G. I know, Mario, and I'm not making money doing this. You know, it's doing this while starving. So all of your support, super hearts, super chats, Patreon account, Rob Braxman Tech Patreon account, buying VPNs, all these are, appreciated. You just don't know how it's appreciated because I'm doing this all for you. I'm not doing anything else. Okay. They should pay for my food. Yes, they should. So it's tough doing this and not making a living doing it. So, but that's what I need to do. I think it's important. So I have a mission here. So please, yes, every little bit helps. So I'm telling you that I'm not making money doing this. So anything that you can help to support the program here is I don't make enough money from doing VPNs or any of that. Hardly any. So spread over years, not much. So I'm basically I'm basically at subsistence living. If you're talking about how much I get paid per hour of broadcast, it's embarrassing. Okay, it's a fraction of the minimum wage. It's embarrassing. So your support, I'll research this for you and do all this, and your support is extremely valuable to me because we have to eat too. Okay, so thank you. So what radio station are you on? What are you talking about? What radio station? What radio station? I'm not on any radio station. I'm not broadcasting on a radio station, nor listening to any radio station. So thank you all, everyone, and sorry for the disruption at the beginning of this video where we lost internet. A lot of this unpredictable stuff here. It used to be on CBS Radio 1. CBS is no longer owning that radio. That radio was sold to iHeartRadio, and I haven't talked to them since it became iHeart. I'm too busy doing that. That doesn't make me money. So I'm just focused on making my channel visible to the world on YouTube. That's number one priority. I think that visibility with the larger population on YouTube is extremely important to what I'm doing. So that's where my focus is. I will watch it someday, but Donzo, who is that person? You will watch it someday? Donzo is just somebody you see here on Periscope. He's on Brax too. So you watch it someday? Okay. You still don't want to watch it. Basically, you don't want to hear the other side of the argument. Anyway, thanks, guys. I got to go back to work. I got work to do, so I shouldn't have scoped this long. I got to go back to work. So thank you so much, guys, and I'll see you tomorrow. You should try and broadcast only on YouTube once a week. I couldn't I, DJ Murdoch? I could try doing that. Okay, you know the other side? No, you don't. Okay, good night. Bye-bye.